Hello, in this class we are going to solve trigonometric equations. We know that sine, cos, tan are all periodic functions. After a period of 2 pi, the same values are repeated for sine and cos, and for tan, after a period of pi, the values are repeated. So if you write the solutions between 0 and 2 pi, these solutions for those trigonometric equations are called principal solutions. So you will be able to write two solutions in the interval 0 to 2 pi. Those two solutions are called principal solutions. Whereas if you write infinitely many solutions for a trigonometric equation, that is called general solution. Infinitely many solutions can be written. So it involves, the general solution involves the unknown quantity n, where n can take any integer value. Now we have to learn the general solution formulae. First formula is, if sin x is equal to 0, sine function takes the value 0 on the x-axis we know. Sine 0, 0, sine pi is 0, sine 2 pi, 3 pi, etc. So in general, I can write x is equal to n pi, where n can be any integer. This is called the general solution. The angles can be negative also. Now let us consider the trigonometric equation cos x is equal to 0. Cos takes value 0 on the y-axis we know. For pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. Odd multiples of pi by 2. So for all odd multiples of pi by 2, cos will be 0, where n is an integer. This is the general solution for the equation cos x is equal to 0. Angles can be negative. Then the third one, tan x is equal to 0. Again we know that tan takes the value 0 for 0 angle, pi, 2 pi, 3 pi, etc. Like sin x is equal to 0. Therefore, the general solution is it can take any multiple of pi, where n belongs to z. These are the general solutions for the given these trigonometric equations. Here also x can be minus pi, minus 2 pi, etc. Now the fourth formula, if you come across a trigonometric equation sin x is equal to sin y, say, we can derive the general solution formula. The derivation you need not learn, but I will show the derivation so that it will be easy for you to memorize the formula. I can write it as sin x minus sin y equals 0. Let us use sin x minus sin y formula, which is 2 cos of x plus y by 2 and into sin x minus y by 2 equal to 0. Product of two terms is 0. Either this must be 0 or the other term must be 0. Cos x is equal to 0. We know that the angle should be an odd multiple of pi by 2. Just now we wrote the formula for cos x is equal to 0. Therefore, x is equal to 2n plus 1 into pi minus y. Let us solve this. Sine of some angle is 0. That means that angle should be a multiple of pi. So x is equal to 2n pi plus y. Let us write the answers putting these two answers together. Therefore, x can take any multiple of pi. It becomes n pi minus 1 whole power n y. If it is an even multiple of pi, it is plus y here. For odd multiple of pi, it is minus y. So it depends upon, the sign of y depends upon the value of n. That's why we write n pi plus minus 1 whole power n times y. If n is an even number, you will get plus y. If n is an odd number, you will get minus y. So we can write the solution putting these two answers together like this, where n belongs to z. So this is the formula for sin x is equal to sin y, general solution formula. Now similarly, we can derive the formula for cos x is equal to cos y. So the answer is 2n pi plus or minus y, where n belongs to z. For tan x is equal to tan y, the general solution formula is n pi plus y, where n belongs to z. This general solution formula can be derived by changing it in terms of sine and cos and simplifying the equation. So these 6 general solution formulae you have to memorize. Exercise 3.4. Find the principal and general solutions of the following equations. First question is tan x is equal to root 3. Here tan x is positive. Tan is positive in the first and the third quadrant. So we have to write two solutions. Those are the principal solutions. Between 0 and 2 pi we have to write. The first quadrant angle is 60 degrees, which is pi by 3, because tan 60 is root 3 we know. And I have to write the third quadrant angle. So first quadrant angle is pi by 3. We call that as a base angle. And I have to write the third quadrant angle. I know that the third quadrant angle is more than pi. So pi plus the base angle you can write. Therefore, the principal solutions are pi by 3 is one answer and 4 pi by 3 is the other answer. These are the principal solutions. Now we have to write the general solution. So for general solution, tan x is equal to tan y. Formula is, I am writing the general solution formula, which is x is equal to n pi plus y. Here this y we write the smaller principal solution, which is pi by 3. N belongs to z. We have two principal solutions. In this general solution formula, in place of y, we write the smaller principal solution, which is pi by 3 in this question. So this is the general solution. Second question. Secant x is 2. Here secant is positive. Secant is positive in the first quadrant and in the fourth quadrant. Cos and secant are positive. Now the base angle, the first quadrant angle, cos 60 is half. So secant 60 is half, pi by 3. So pi by 3 is one principal solution, and fourth quadrant angle is 2 pi minus. So always go with this pi and 2 pi. If it is the first quadrant angle, we take it as theta, which is the base angle. If it is in the second quadrant, we do it as pi minus the base angle, pi minus theta we write. If it is in the third quadrant, we write pi plus theta. If it is in the fourth quadrant, we write 2 pi minus theta. So 2 pi minus pi by 3. Therefore, the principal solutions are pi by 3 and 5 pi by 3. These are the principal solutions. Now let us write the general solution. For general solution, we have only for tan, sine and cos. So let us change this equation to cos. Cos x is half. So the general solution for cos x is equal to cos y is x is equal to 2n pi plus or minus y. I told you we write the smaller principal solution, which is pi by 3. This is the general solution where n is an integer. Third question. Cot x is equal to minus root 3. Here cot is negative. Cot is negative in the second quadrant and in the fourth quadrant. Now let us write the base angle. Base angle we write for plus root 3. Cos 30 is plus root 3, we know. So the base angle is pi by 6. But we need the second quadrant angle. Second quadrant angle is pi minus the base angle. And the fourth quadrant angle is 2 pi minus the base angle. Here it is 5 pi by 6 and here it is 11 pi by 6. These are the principal solutions. Now let us write the general solution. General solution formula we have for tan. Let us write this in terms of tan. Tan is minus 1 by root 3. Therefore, the general solution for tan x is equal to tan y is n pi plus y. N pi plus y is the smaller principal solution we write, where n belongs to z. Fourth question. Cosecant x is minus 2. You can do with cosecant or you may change it because general solution we have for sine. So sine x is minus half. Now sine is negative. Sine is negative in the third and the fourth quadrants. Now the base angle. Write the base angle for plus half. Sine 30 degrees is plus half, we know. So pi by 6 is the base angle. But we need the third quadrant angle. Third quadrant angle we write it as pi plus and fourth quadrant angle we write it as 2 pi minus. So pi plus the base angle gives you the third quadrant angle and 2 pi minus the base angle gives you the fourth quadrant angle. These are the principal solutions. Now we will write the general solution. Sin x is equal to sin y. The general solution is n pi plus minus 1 whole power n times y. N pi minus 1 whole power n. We write the smaller principal solution where n belongs to z. This is the general solution for the given equation. Now fifth question. Cos 4x is equal to cos 2x. We have two methods to do this. I can solve the question keeping the equation like this itself. Or you may bring that cos 2x to the left hand side, but that is a longer method. We will do it directly like this. So cos x is equal to cos y, general solution formula we will write. Here we have to find only the general solution. So here we have 4x on the left hand side. I will write the formula. Cos x is equal to cos y. The general solution formula is x is equal to 2n pi plus or minus y. This is the general solution formula. Here in this question we have cos 4x equals cos 2x. So my x is 4x here, 2n pi plus or minus my y is 2x. But I have to solve for x. I cannot have x on the right hand side as well as on the left hand side. I have two equations to solve. One is 2n pi plus 2x and the other equation is 4x is equal to 2n pi minus 2x. Let us find x from this. 2x is 2n pi by taking 2x to this side. So we get one of the answers as n pi, and here 6x, that is taking minus 2x to this side. And we get x is equal to n pi by 3. So we can write therefore the solution is x is equal to n pi or x is equal to n pi by 3, where n belongs to z. Sixth question. Cos 3x plus cos x minus cos 2x is 0. Let us use formula cos x plus cos y formula. Cos with plus sign will be both cos product. 2 cos of x plus y by 2 and cos x minus y by 2. Let us use this formula. So this becomes the first two terms, cos 4x by 2 and cos x minus y is 3x minus x, which is 2x by 2 minus cos 2x equal to 0. So 2 cos 2x into cos x minus cos 2x is 0. While solving a trigonometric equation, you have to factorize. Take out the common terms. We get cos 2x is common. We get 2 cos x minus 1 equal to 0. Now we have two factors. Product of two terms is 0. So either this must be 0 or the other term must be 0. Here we have to use cos x is equal to 0 solution. So 2x is odd multiple of pi by 2 is the answer. We have to find x. X is equal to 2n plus 1 times pi by 4. And here let us solve this. Cos x is half. Cos is positive in first quadrant and fourth, but we have to write the smaller principal solution, no? The formula, the general solution for cos x equals cos y. Here some value is there, so we have to use the formula cos x is equal to cos y. The general solution is 2n pi plus or minus y. Therefore, x is 2n pi plus or minus the base angle. For half, the angle is 60 degrees. So, pi by 3 is the smaller principal solution, where n belongs to z. So, the solution may be like this or like that. Next question. Question number 7. Sine 2x plus cos x is 0. I am using sine 2x formula, which is 2 sine x cos x. I have told you while solving the trigonometric equation, factorize by taking the common factors out. And we get this. Now we have product of two terms equal to 0. Either this must be 0 or the second term must be 0. Here we get sine x is equal to minus half. cos x is equal to 0. So we have to use the general solution formula of cos x is equal to 0. X must be an odd multiple of pi by 2. Let us solve this. Sine is negative. Sine is negative in third and the fourth quadrants, but we take the smaller principal solution. Let us find the base angle for plus half. The first quadrant angle is the base angle. And sine 30 degrees is plus half, we know. But we need y. Y is the third quadrant angle. For third quadrant, we write it as pi plus pi by 6, which is 7 pi by 6. Now the general solution for sin x equals sin y. We have to use the formula sin x equal to sin y. The formula is x is equal to n pi plus minus 1 whole power n times y. We get n pi minus 1 whole power n. Y is 7 pi by 6. Therefore, we will write the general solution. X is equal to 2n plus 1 times pi by 2, or x must be n pi plus minus 1 whole power n 7 pi by 6, where n belongs to z. N can take any integral value, integer. Eighth question. Secant square 2x is equal to 1 minus tan 2x. Since the other side is in terms of tan, we will change secant square in terms of tan square. The identity is secant square theta is 1 plus tan square theta. Let us use this identity. It becomes 1 plus tan square 2x equal to 1 minus tan 2x. Bring that tan 2x to this side, so it becomes plus tan 2x. I told you to factorize by taking the common factors out. We get product of two terms is equal to 0. We have factorized. Either the first term should be 0 or the second term must be 0. Now we have to use tan x is equal to tan y general solution. Tan x is equal to 0 general solution formula, which is n pi. But here the angle is 2x, so 2x is equal to n pi. We have to solve for x. Let us solve this. Tan 2x is minus 1. Tan is negative in the second and the fourth quadrants. But we take the smaller principal solution to write the general solution. Let us find the base angle. Base angle is the first quadrant angle for plus 1. For plus 1 it is pi by 4. Base angle is pi by 4. But our y is the second quadrant angle. Second quadrant angle we write it as pi minus pi by 4, which is 3 pi by 4. This is our first principal solution. Now we will use tan x is equal to tan y general solution formula. So tan x is equal to tan y general solution formula is x is equal to, our x here is 2x. N pi plus y is the formula. N pi plus y is 3 pi by 4. Therefore, x is n pi by 2 plus 3 pi by 8. Now let us write the answers together. x must be n pi by 2 or x must be n pi by 2 plus 3 pi by 8, where n belongs to z. Ninth question, sin x plus sin 3x plus sin 5x equals 0. Let us combine these two terms so that sin 3x will be common. We are going to use sin x plus sin y formula, which is 2, both are sin here and plus sign, so sin first and then cos. So sin x plus sin 5x. I can write bigger number. I will write sin 5x first to avoid negative sign, plus sin 3x equals 0. Apply the formula. 2 sin 6x by 2, which is sin 3x, and cos x minus y is 5x minus x, 4x by 2, which is 2x. Sin 3x is common. We get 2 cos 2x plus 1. We have done factorization. Product of two terms is 0. Either the first one should be 0 or the second term should be 0. Here we have to use sin x is equal to 0 formula. The general solution formula is x is equal to n pi, but here in place of x we have 3x. Therefore, x is n pi by 3. Here we have minus half. Cos is negative in the second quadrant as well as the third quadrant, but we have to write the smaller principal solution in the general solution. Now let us see the base angle for plus half. For cos 60 degrees, this is the base angle. The general solution for cos x is equal to cos y. The formula is x is equal to, but here x is 2x in this question. So 2x is 2n pi plus or minus y is the formula, and y is the second quadrant angle, pi minus the base angle, which is 2 pi by 3. Therefore, x will be n pi plus or minus pi by 3. Let us write the general solution. So, x can take the value n pi by 3 or it can take values n pi plus or minus pi by 3, where n belongs to z. Now page 77, example 23. It's a similar question. Sin 2x minus sin 4x plus sin 6x equal to 0. We will combine the first and the last terms. So I'm going to combine this. I wrote the bigger number first. Both are positive. So I can write sin 6x first to avoid the negative sign in the formula. Now sin x plus sin y is 2 sin x plus y by 2, 8x by 2, which is 4x, and then cos 6x minus 2x, 4x by 2 is 2x, so that we have sine 4x common. I am taking sine 4x out. We get cos 2x minus 1 equal to 0. So we have product of two terms which is equal to 0. Either the first term should be 0 or the second term should be 0. Now for this we have to use sin x is equal to 0 general solution formula. X is equal to n pi, but here x is 4x. So I should write 4x is equal to n pi. Therefore, x is n pi by 4. Now let us solve the other equation. Cos 2x is half. It's positive in the first quadrant. First and the fourth quadrant, but the smaller principal solution we have to take. So base angle itself we are going to use as y. 60 degrees. Cos 60 is half. Now we have to write the general solution for cos x is equal to cos y. So the general solution formula is 2x is equal to 2n pi plus or minus y. Y is pi by 3 here. We have to write for x. Now let us write the solution. So x can take the values n pi by 4 or x can take n pi plus or minus pi by 6 for any integer n. This is the general solution. For different values of n, we get different answers. So infinitely many solutions are there. Example 24. The given equation is, this is an important question. Two cos square x plus 3 sin x is equal to 0. Since the second term is in terms of sine, we will change cos square also in terms of sine. Using the identity, cos square x is 1 minus sine square x. Let us open the brackets. We get a quadratic equation in sine. Plus 3 sin x plus 2 equal to 0. Let us change the sign throughout. We are going to factorize this quadratic equation. Product should be minus 4. Sum should be minus 3. So I can split it as 4 minus 4 plus 1. Let us split the middle term. Minus 4 sin x plus 1 sin x. Now from the first two terms, 2 sin x is common, and from the last two terms, 1 is common. Now sin x minus 2 is a common factor. We get 2 sin x from the first term and plus 1 from the second term. We have done factorization. Product of two terms is 0. So either the first term should be 0 or the second term should be 0. Here sin x cannot take the value 2. Not possible. Sin x cannot become 2 because write the reason. Sin x takes values between -1 and +1. We know that cos and sin, they take values only between -1 and +1. So more than 1 is not possible. Let us solve the other equation. Sin x is -half. Sin is negative in the third and the fourth quadrants, but we take the smaller principal solution. Let us find the base angle for +half. So for +half, the angle is 30 degrees. But here it is negative. Therefore, we have to write the third quadrant angle. Y should be the third quadrant angle, pi plus the base angle, which is 7 pi by 6. Let us write the general solution for sin x is equal to sin y. The formula is x is equal to n pi plus -1 whole power n y. Now we are substituting. Y is 7 pi by 6, where n belongs to z. So x can take any value of this form. That's all, the exercise is over. 8th question of exercise 3.4 is also an important question. Put a star in your textbook and practice these questions. You may get 6 marks or a 4-mark question solving the equation.